Hello guys, this is the map tutor, and in today's video I'll be solving this problem. We have a square with side length A, and there will be charges Q on each of the vertices of the square. The question A is to determine the electrical field intensity in the center of the square. So let's start with question A. Let's draw the square. There will be positive charges on each of the vertices here, 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 and here. Let's call that 1, 2, 3, and 4. So the concept of the electrical field is basically the force that is result of putting a test charge that is positive on a point. In this case, there will be a positive test charge in the center of the square. So there will be, with that force, there will be a creation of different fields. But because it is positive and the charges are equal, the four fields that will be created will have the same magnitude. And the directions will be this one. In this case, the charge with the center and this charge will be in this direction, this field 1. Field 2 will be in this direction, field 2, and field 3 will be in this direction, so on until field 4 is created. So we can observe that all the fields have different directions and they are opposite, so they will cancel each other. Field 2 will cancel with field 4 and field 1 will cancel with field 3. So we end up with a sum of all the fields being equal to 0. But that's not all. We can also find the potential. And the potential is the work that is necessary to move a charge from the infinite to the given point. In this case, well, the center of the square. And there's a formula for that. For each of the charges, the potential will be equal to 1 over 4 times pi times this constant multiplying the charge over the distance. And the distance we can observe is basically the half of the diagonal, the distance from the center to all of the vertices. And this is, if we have A and A, the diagonal will be square root of 2 times A. So the half of the diagonal is square root of 2A over 2. So the potential will be equal to 1 over 4 pi times a constant multiplying Q, the charge, over square root of 2A over 2. So the potential on one vertex will be 1 over 4 times pi constant multiplying the square root of Q over A. But there are 4 vertices, so the total potential, let's call that potential T, will be equal to 4 times the potential in one of the vertices. So this 4 will cancel with this, and we end up with a square root of 2q over pi constant times A. And that is the potential, the first question we have, the electrical field and the potential. So let's continue. We also, in the second question, we have to find the charge which charge Q do we have to place at the center of the square so that the overall forces acting on every charge are zero. So let's draw again the square. I can draw a square here. Alright, with side A, again the charges. But in this case, the easiest way to solve that part of the problem is to observe that the forces acting upon one of the sides will be equal to the other ones. So to find the overall forces acting on each of the charges, we can do it on only one, and that will work for all of them. Again, 1, 2, 3, 4. Because these are positive, the force that will be created from charge 4 and charge 2, let's call that force 4, will be of repulsion, force 4. The force created by the charge 1, force 1, will be also repulsive, and the same with the force created by force 3. So let's find out the sum of these forces. We can do that using Coulomb's law. We know that the force is equal to a constant K times this the two. In this case, let's do it with force 3. With the two charges. In this case, charge 2 times charge 3 over the distance between each other to the square. And we observe that the distance between charge 2 and charge 3 is A. And we observe also that all of the charges have the same value. So this will be equal to K Q squared over the distance squared, A squared. And this will be the same that in the force 1. So we have this equality. Force 3 is equal to force 1. What else? We got force 3, force 1, but we are looking for force 4. Force 4. Force 4 will be K times the charge squared again. But in this case, the distance will be the whole diagonal. And the whole diagonal is square root of 2 times A. So we're looking for this total force, the force Ft, which is equal to the sum of all the forces. But to make it easy, we can first sum, because we have here force 3 and force 1, we can create a force that is in the same direction that force 4. Let's call this force 3, 1. The resultant. And the resultant using the Pythagorean theorem will be, well, we can represent this in an easier way because we know that F3 is equal to F1. We can represent this as F1 plus F1. So using the Pythagorean theorem, we got that the square root of F1 square plus F1 square is equal to F31, and that is square root of 2 plus, no, plus no, square root of 2 F1. What else? We put this on the sum, and this will be equal to the F4 plus F1, 3. So we can sum this. We know that F1, 3 or 31 is the square root of F1, and F1 is K times Q squared over a squared. This, we sum this to f4, which is k q squared over the square root of a, and this is to the squared. I must forget that we square this. We can extract a common factor, k q squared a squared, and we get here square root of 2 plus 1/2. All right. What else do we need in this problem? We need to find the charge that is created from the center to any of the vertices. We also use Coulomb's law, but in this case the charge will be Q, and this is what we are looking for. Let's call that force. This force will be in this direction. I mean, if we can call that force prime, the force between the center and our example charge is charge 2. So curious about the charge 2 will be a fourth prime, and that fourth prime will be equal to, again, the Coulomb's law, k times the big Q times the smaller q that we are looking for, and the distance will be half of the diagonal. So the diagonal is square root of a over 2, the half of the diagonal, and this is all squared. So this will be k q times 2 over a squared, and we are looking for this q to cancel. I mean, the resultant force Ft must be equal to the force prime to cancel each other, because we're looking for an overall forces of 0. So we must equalize this, F prime being equal to Ft. Let's do that. We got k q 2 over a squared is equal to k q squared over a squared times square root of 2 plus 1/2. A's will be cancelled out, this square will be cancelled out, this k will be cancelled out, and we only end up with q being equal, we clear the variable, to square root of 2 plus 1/2 times q over 2. And this is equal to q times 2 times the square root of 2 plus 1 over 4. And that's the solution of the problem.